Okay, using the worksheet that you guys have today, I'd like you to find the problem r equals 4 sine of theta. It's on the side that does not have adjectives. Is that correct? Oh, 2 sine of theta. We'll do this one. Let's flip over onto the side that does have adjectives. Okay, awesome. Here we go. So 4 sine of theta. That is one of our problems on there. Please find it, and we're going to go from there. Today, guys, we are graphing polar. And so how do we graph polar? By radiuses and angles. So we're going to do a T-chart first. Does that make sense? Everybody with me? You good? Yeah. Okay. T-chart. We're going to do it this way, and then I'm going to show you another way to do it, which I prefer. Okay? So, we're holding this today. So, here's a T-chart. Okay? And today I still encourage you guys to use your calculators. Once again, right? I want you to be a calculator. But I want it to guide you, not do the work for you. Okay? I want you to make sure you're getting the whole graph and not just a part of the graph. Everybody there with me? So let's go ahead and plot that in to our calculator really quick. So everybody hit y equals. Miss Boucher has it, so I'm going to hurry. Oop, that ain't it. Never mind, I'm not doing it. You have to go to y equals. Okay? And you're going to plug in 4 sine of theta. Remember, theta is xt theta. It's the normal x button. I would like you guys to make sure you're all in radian mode. Check your mode really quick. Are you in radian mode? Then I'd like you to hit graph. As I'm waiting for you to graph this, this is the graph that I got when I looked it up online. Okay? So, just you guys have graphs with circles already. I just need to make one. Look at those. Those are pretty, huh? Okay. So, what we have here is, notice, when I plug in 0 for sine, for the theta, and this is r. So when I plug 0 in for the theta, what do I get for r? What is the sine of 0? 0. And what's 0 times 4? 0. So at my radius of 0, my theta is 0, so it is at the origin. Does everybody understand how it's at the origin? Okay. Give me another value that we usually pick. Pi halves. Okay, I'm going to leave a little space because I actually do have to come back and use some of these, but I'm going to show you why it's important, why we need to pick those other values. So if we pick pi halves, what is the sine of pi halves? 1 and 1 times 4? 4. Okay, all I'm doing is plugging the value in for theta to get the r value, correct? So therefore, pi halves is on this axis right here, right? So therefore, I'm going to put a point right there. Okay. Now, do I just draw a straight line there and connect those? No, because there's many missing values in between. If I went ahead and picked pi as well, okay, if I pick that, the sine of pi, 0, 0 times 4, 0. So at pi, I'm at 0. Notice I'm back there. Okay, so I only technically have 2 points. But is this what the graph is, what you guys have on your calculator? You guys have an ellipse on your calculator, don't you? Okay. Did I tell you guys all to be in Zoom standard, not Zoom standard, but Zoom trig? Let's go there really quick. So hit the Zoom button and hit number 7. We all should be on the same because we're all in radian mode. We okay? Do we all get the ellipse? If you're having calculator problems, that's something we'd have to fix a little bit later, okay? Okay, now, notice it's not giving me the exact same graph, it's only giving me 2 points. That's where these other points come in. I'm going to pick pi 6. So if I plug in pi 6 for sine, the sine of pi 6 is a half. A half times 4 is 2. Whoa, Betsy. That's a, Shoot. Notice here, guys, this should have been 4, and I only did 2, huh? Oh, fricker frackers. Just 30 seconds. Love you all. You're all good people. B5. Shout out to, who am I shouting out today in B5? We're going to shout out, who am I shouting out, guys? Kayla Barrett in B5. Hannah Clark, your old class says hi. Say hi. Hi. There you go. See? Here's my more accurate points. I apologize, is that lovely greenish ugly color. Okay? So, now, at pi 6, which is roughly out here, notice I'm drawing a little line. At pi 6, I'm at 2, huh? Okay? Now I'm going to go ahead and do pi force. Pi force, where's that at? Okay, so I come back here with this ugly greenish color. Pi force is more straight. Now when I plug that in, that is root, we can go with it. Root 2 over 2 times 4, which is 2 root 2. This class, hurry, somebody tell me what 2 root 2 is, please. I hear a 2.85, 2.84, 2.84. Okay, so here I got 2.84. Okay, let's hurry and do pi thirds. I don't want to go over this stuff, so I'm going to come over here. Notice that's 4. Sine of pi thirds is root 3 over 2. So that's 2 root 3. Can somebody help me out with 2 root 3, please? 2, huh? 3.46. Okay, so I go out to pi 6 roughly. Okay, pi 6 is more this angle here. And I need to go out 3.46, so roughly there. So if I connect that, there's that other half of that graph. There's the half of that graph on the side, right? Does that make sense to everybody? Okay, now, back in first quarter, we learned about what we call even and odd functions, right? If you recall, an odd function was symmetrical about the origin, meaning that if I had the point x, y, that would go to negative x, negative y if it was odd. Notice, but it reflected about the origin. If it was an even function, if I had the point x, y, I could replace x, but I'd have the same y. Does everybody remember that? This is odd, and this is even. Not that you guys need to know even or odd right now, but there is some other symmetries. I'm going to come back and finish this graph in just 30 seconds. Let me hurry and just show you with this ugly green again, where it's at. It's kind of harder to see. So right there. Is everybody with me on that? Okay. I'm going to share some rules with you. Can you guys see the down arrow? I know. Yeah, well, we'll go to a next page and come back. So we're going to come back to that other graph and finish it up, but just give me 30 seconds here. What I'm going to do right now for you is I'm going to teach you some rules. If you are symmetrical about pi halves, the angle theta equals pi halves, notice, remember that is a line. Well, where is pi halves? Pi halves is right here. Notice if it's positive, it'll be on the upper part with a positive radius, right? But if it was negative radiuses, it would be below the x-axis. Recording a video for tomorrow morning because of the assembly. Okay, meaning if it reflects about this, if I graph something such as, let's say we had this side of our graph already, correct? If it is symmetrical about this, what does it look like? It's a mirror image on the other side. That is a mirror image. That is a mirror image. I suck at drawing. Okay. But that kind of looks like our oval, right? But how do I know if it is symmetrical about pi halves or in general, the y-axis? Well, you have to do this. Right now we're in r theta, aren't we? So I need to go ahead, if it is reflected, the negative r, negative theta, would work and come back to the same equation. Does that make sense what I'm saying? Yes, sir. So, for our last example, we had this formula. Correct? Let's see if it is symmetrical about theta being pi halves, or in our way, we're kind of thinking about it, the y-axis. Okay? So with that being the case, I'm going to replace r with negative r, and theta with negative theta. Now you got to remember, back when we did identities, what does sine of negative theta equal? Negative sine of theta. What does cosine of negative theta equal? Just regular cosine of theta. Remember, it absorbs it. Do you guys remember those basic identities? If not, you better learn them now. Okay? So, what does this become because I have negative theta? I have sine of negative theta. This then becomes negative 4 sine of theta because that negative comes on the outside, doesn't he? And this guy was negative r, so if I do it to both sides, what happens? If I divide both sides by negative 1, I come back to my original equation. That's a weird sign. Okay, I get back to my original equation, so therefore this is symmetrical about pi halves, right? So then I can come back over here, and let's finish up our graph. Okay, so therefore, on my graph, I know it's symmetrical. Here at pi 6, it was at 2. So at 5 pi 6, I'm at 2. With me? At 3 pi 4, so at pi 4, I was 2 root 2, which was, you guys told me it was 2.84. So at 3 pi 4, I'm at 2.84. At pi thirds, I'm at 3.46. So at 2 pi thirds, I am at 3.46. Does that make sense to everybody? So I just have these values, and boom, it looks like what was on your graph, correct? On your calculator. Now our whole goal today is to graph these via pie chart, not pie charts, but T-charts. Or the other way I graph is via a graph itself. Let's go to another page, okay? And I'm going to show you what I mean by that. I'll come back to this page as well. Okay, so now I'm going to go ahead and do the same problem, but I'm going to do it a different style. Okay, r equals 4 sine of theta. Let's go back to when we actually graphed trig functions. So I'm going to change this in a way, just bear with me. So notice the y is the r, the x is the theta, right? Everybody there? Okay, here's my graph. What's the highest this graph's ever going to go? 4. What's the lowest this graph's ever going to go? Negative 4. Okay, this is a sine graph. What was its normal values I used to graph sine? Pi halves, pi, 3 pi halves, and 2 pi. Is everybody with me? Yes, that is the rest of the year for her class. Not my class, but you're not her class. Yes, it's very limited. Okay, let's try and stay right here for me. So I'm going to graph the sine graph. Remember, sine graph starts on the midline, goes up high, midline, low, midline, right? Everybody see the graph? With me? Okay, watch this, ladies and gentlemen. Okay, once again, we had a circle 1, 2, 3, 4, right? On the same graph we just barely did. Correct? Okay, so we're going to look at this part of the graph here. Notice from 0 to pi halves. At 0, where did I start? 0. At pi halves, where did I end? 4. Now notice, guys, as I go larger angles, what's happening to my radiuses? It's getting higher, isn't it? So as I go larger angles, I get higher radiuses. Larger angles, higher radiuses. Kind of see what I have there? More circular shape. I'm asking you to just roughly sketch this a little bit. Okay? Now, let's go ahead and do this part. I'm going to do it in red really quick. Notice from pi halves to pi. Where does pi half start at? 4. Where does pi end up at? So at pi, I'm at 0 radius, so back at the origin, huh? Notice, as I get closer to pi, meaning my angle is getting larger, so going that direction, correct? My y value is doing, excuse me, not my y value, my radius is happening to do what? Getting smaller. So meaning, as I go larger angles, my radius is getting smaller. Notice that's a good oval, isn't it? Okay, are you guys okay with it? Is it a great sketch? No, it could be better, right? But at the same time, I use that information. Now, we've only did that part of our graph, correct? Let me show you the rest of it. Yes, sir. We're not worried about tangents right now. Okay, he asked about tangents. So I'm going to go ahead and graph this part, which is from pi halves to 3 pi halves. Now notice, guys, that's down here, isn't it? But look at my radiuses. What is it? My radiuses are negative. So where does that go? That puts me, everything I had in here is going to be up in quadrant 1 because I have to push through, don't I? So basically, doesn't that just give me that part again? Does that make sense? And what does this part do right here? From 3 pi halves to 2 pi. That's going to push through because its radiuses are negative up into quadrant 2. Hence, I'm graphing that part, so it just does it again, doesn't it? Okay? Does everybody understand how looking at a graph can also graph it by being a little less exact, but we can get a general idea, correct? Okay. Now notice, that was when we are reflected about pi halves. That was pi halves, huh? We were reflected about that because it had that symmetry, correct? Okay, let's go back here. There's another one that you need to be careful with. Okay. Oh, fricker frackers. Where is that sucker? Love Miss Boucher. Thanks for helping. Shout out, Bouch. Okay. The other one that is it's called the polar axis. And that's basically the x-axis. And what happens here is if you have r theta, and you can replace it with just negative theta and get the same angle, that is symmetrical about the polar axis. Okay? And if we think about that, what trig function has that symmetry? Cosine, right? Because the angles are opposite, but it still gives us the same x values. Correct? Okay, so we're now going to go use that. Okay, so staying on that same side of your note paper, can you guys give me another equation, please? I don't want that one back. I want a 2 plus something, or 2 plus. Okay, so I have r equals 2 plus cosine theta. Is that correct? Okay, me personally, I like to graph this via a graph. So I'm going to graph him first. Does that make sense to everybody? Okay, so here we go. How high is this going to be? What's the highest it'll ever be? 3. Because once again, what's his amplitude? 1. So if I go up to 2, notice that's your midline, right? And then because of my amplitude, the highest I'll be is 3. The lowest I'll ever be is 1. Does everybody understand that? Now, is anything happening to my theta? Is it more than just theta? Is it 2 theta, 3 theta, 4 theta, anything like that? So it's not, so therefore I'm going to just keep the same tick marks again, which are pi halves, pi, 3 pi halves, and 2 pi. Okay. I would like you guys, can I ask you a question? How do I extend the page down? Over there. I saw him over there now. Oh, I just saw it. Thank you. Okay, so I'm going to graph this. Here we go. Notice, remember, cosine starts up, midline, low, midline, high. Oops, a little higher than I wanted over on the far side there. Oh, that's bad. We'll erase that. There we go. That's a better graph, isn't it? Okay, we are going to graph this now using polar coordinates. Okay? So using polar coordinates, what's the highest radius I'll ever use? Look at our cosine graph. What's the highest radius I'll ever use? 3. What's the lowest I'll ever use? So I have radius of 1, 2, 3. Now, I'm not an artist. Hopefully that looks good. You guys have good examples with angles, right? So it helps you out a little bit better, doesn't it? And that's how it'll be on your test. You'll be given something in a polar graph like what you are giving right now. Okay? Everybody there with me? Okay. Here's what we're going to do. I'm going to do this in parts. So I'm going to start right here in purple, and I'm going to do this part. Okay, notice which was 0 to pi halves. At 0, where am I located? What's my radius? 3. When I get to pi halves, what's my radius? 2. So therefore, I am here. Notice I've went in on my radius. Notice as my angle gets larger, meaning as I go that direction, what's happening to my radius? It's going down, and hence why from 3 to 2, huh? So I'm going to go ahead and kind of sketch that. That was bad. Where's my undo button? You scallywag. There we go. Everybody see that? Yes, no? Okay. The next part that I'm going to do is going to be in black here. Ooh, black might not be very good. This pink color, which is from here to here. From pi halves to pi. Notice at pi halves I'm at 2, but at pi where am I located? 1. So at pi I should be on 1, which is right there, correct? Notice my angles are getting smaller. Yeah? Not my angles. My angles are getting larger. My radiuses are getting smaller, correct? Does everybody see that? Okay. Now notice, guys, I've only completed half of my cycle, haven't I? If I keep going, I'll probably get the rest of the graph. Let's keep going. So, I'm going to use this ugly green again. And that'll be this portion from pi halves to 3 pi halves. Okay? From pi to 3 pi halves, that's down here in this quadrant. Correct? And notice, I am going from 1 at pi, back at 3 pi halves, I'm going to be at 2. So basically, as my angle gets larger, so does my radius. Correct? Yes? All right. Last but not least, we'll do this ugly. Have we done orange yet? No. Oh, we did. We'll do that part, which is from 3 pi halves to 2 pi. So down here, notice I'm going to connect here. So notice my angle's getting, not my angle. My angle is getting larger, but so is my radius, correct? Notice my radius is going higher. It's increasing, isn't it? Huh? I did. It's called I think this is called a cardioid. I'd like you guys to check via your calculator to make sure that we have the same graph. Because if not, what if that didn't plot my whole graph? What do you got to keep doing? More cycles. Does that make sense? I would keep going to 4 pi, or I could have went vice versa. I could have went backwards to negative 2 pi. So they said just to make sure if that didn't give the graph exactly the same as what you were looking at, then you go ahead and extend your period to more periods than what we had up there. Okay? Okay, now remember, I just barely went over on this guy. Oop, not that one. We talked about how we are about the polar axis, huh? Was our cardioid, I think that's what that was it symmetrical about the x-axis? Look at our graph, what we ended with. If we folded on the x-axis, wouldn't they lie right on top of each other? Okay, so with that being said, I could have stopped because I'm going to check just to make sure. Notice r equals 2 plus cosine of negative theta. Remember, I replaced theta with negative theta. And what is the cosine of negative theta? That absorbs that negative, so it's right back to 2 plus cosine of theta, our exact equation, huh? Is everybody with me on that? So notice I could have stopped up here. I'm going to do this in black really quick just so you know. This was our original first part. I could have used symmetry to just go ahead and do that again. I didn't have to keep going on my graph because it does have symmetry. Okay? Any questions so far? B5, I'm sorry I'm not there to answer questions. Love you all. Okay, let's go ahead and try another one. What else you got on that side? Okay, 3 plus 4 sine of theta. I actually like that one. R equals 3 plus 4 sine of theta. Okay, so me personally, once again, I start to graph. Okay, where's my midline, ladies and gentlemen? 3. Okay, that is my midline, huh? Is everybody with me on that? Yes, no, maybe so? How high, how much higher do I go from my midline? I go up 4 and down 4, correct? So the highest I'll ever be is 7, and the lowest I'll ever be is -1. And that makes sense because the highest sine ever be is 4, so 4 plus 3 is 7. The lowest sine will ever be is -1. -1 plus -4, excuse me. The lowest will ever be is -4. -4 plus 3 is -1. Does that make sense where that comes from? Okay. So, once again, looking at theta, is there anything playing around with theta? Nope, it's not. So, therefore, I still have pi halves, pi, 3 pi halves, and 2 pi. Is this a sine graph or a cosine graph? So, we will start at the midline. Everybody see where my graph came from? Now, is this the only way to graph these things? What else could I do? Pick a lot of angles and do a T-chart, correct? Everybody with me on that? Okay. Here we go. What's the highest I'm ever going to be? So I need 7 of these guys. 1, 2, 3, 4, 5, 6, 7. Okay, once again, not an artist, but you're getting the idea of what I'm doing, right? Okay, on your sheet, as these students are telling me, you only have 5, so just make 2 more really quick. Okay? Okay. I need everybody to stick with me today on this one. This one's probably a trickier one that I'm going to have to go over, okay? All right, here we go. I'm going to do this in blue. Actually, blue, I'm going to do the whole thing. So, the first thing I do is I just do it in portions. Notice I start here, and I do this portion. So where do we start at? At 0 radians, what is my radius? 3. 0 radians is 3 radius. So that's 1, 2, 3. I'm starting here, am I not? Is everybody there with me? Okay, notice at pi halves, where am I going to be? 7. So I kind of like to do the starting point and the other point, and then I look up at my information. Notice as the angles get larger, what's happening to the radiuses? They are getting larger as well, correct? So notice hence why I went from 3 to 7, because of the fact that it is getting larger. And I'm just sketching this. Just sketchy sketcher. Okay? You with me? Will, it's a good time to calm down. I will answer questions later, Will, I promise you. If you have questions, let me help out. I'm talking to my man Will in B5 right now. Will Thompson, if you're in there too, I love you too. Okay, so now we're going to do from pi halves to pi. So at pi, I'm back at 3 radius. Notice, as my angle is getting larger, what's happening to my radius? It's getting smaller. So therefore, that's why it comes back in. Notice, look at all the radiuses getting smaller to him. Is everybody with me? Okay, here's the tricky part. I need everybody's eyes. Really pay attention to what I'm doing right now. I'm going to go to this green part. Notice, I have a part of this next section that is positive, and then I have a part of this next section that is negative. I'm going to graph those sections on this in their designated colors. Does that make sense to everybody? Okay, so the first part of the graph right here, which is green, is from pi to somewhere in pi halves, or the third quadrant, right? I could solve and figure out where it equals that number, but whoopity darn do. Okay? What I'm trying to say is, notice in this part, they will have positive radiuses, so I just use the radiuses out here, don't I? Now notice it's getting smaller and smaller and smaller, closer to 0, so basically it's this. There's a point that I have to go back to 0, isn't it? Because my radius is 0. Does everybody see that? It is positive. See, notice my radiuses are still being positive. Okay, now here's the part that you have to think about. Okay, this part is still in quadrant 3, isn't it? But look at its radius. What is it? It's negative, isn't it? So therefore, I have to push through, don't I? Notice at 3 pi halves, what's my spot? -1. So here's 3 pi halves 1, but because it's -1, it pushes me up through to there, doesn't it? So I need to connect this part. Now understand, all this stuff that was going to be in here for the angles is going to be pushed through, so it comes up like such. There's going to be a little loop on the inside of your graph. Okay? Now, I'm going to come back and use orange here to do this part. Notice we have the same situation, don't we? For this little part of your angles, your radiuses are negative, aren't they? So where do we get pushed to? The second quadrant. So that's why he's going to come around and be over there. With me? And then, if you'll notice, from here on out, it's just what it is, right? So at 2 pi, I'm back at 3. Where I went from 0 to 2 pi, boom, notice, there's our graph with a little loop on the inside. Okay, when the loop happens is when your radius goes below 0. Because then you got to reflect it onto the other sides, don't you? Something to look at. If your radius ever gets below 0, you're going to most likely, in this case, where it's just a little bit part of our graph, that's below 0, correct? That's going to make the little inside loop for you. Okay? That was a tricky one, but it's not too shabby. Okay? All right. Let's finish up on the last one. I can answer questions. B5, when you have time, we'll do it on Friday as well. Everybody good? Okay. I'm going to go to the next problem. All right. What's the last one for that page? 5 cosine of 2 theta. Okay. R equals 5 cosine of 2 theta. Notice, ladies and gentlemen, we no longer just have a regular theta this time, do we? We have a 2 theta. So what does that do to our graph? Notice, once again, our midline is going to be at 0. 1, 2, 3, 4, 5 is my high. 1, 2, 3, 4, 5 is my low, negative 5. Correct? So with this being the case, we usually use pi halves, pi, 3 pi halves, and 2 pi. But because it's 2 theta, what do we do to those items? We cut them in half or divide them by 2, right? So therefore this is pi fourths, pi halves, 3 pi fourths, and pi. Is everybody there with me? Does everybody understand why we have to do that? What if that sucker was a 5? What do we have to do? We got to go ahead and divide them by 5. So I'd use pi tenths and so on, right? Okay, so remember cosine starts up high, midline, low, midline, high. Okay, so what's the largest? How many radiuses are we going to need? 5, because even when it's negative 5, that'll still be on radius 5, correct? So I have 1 radius, 2 radius, 3 radius, 4 radius, 5 radius. Is everybody there with me? Okay. So, once again, we just go piece by piece, okay? So what I do here, by the way, did we check in via our graph if we got the same graph on the last problem? Did we check to make sure that this graph is what our graph looked like on our calculator? And it should be looking like that. Remember to do it. Remember, I am okay with you checking with your calculator. I just want to make sure you're doing the work and understanding how to get to that thing. Correct? How to get to that graph. Okay, so let's continue back to our other problem. I'm going to do this in red, and we're just going to go at it. Here we go. So pi fourths, sometimes I like to do my little angle. Here's pi fourths, meaning that's our first quadrant, from 0 to pi fourths. That's what we're going to be using, correct? Okay, so at 0 degrees, or 0 radians, excuse me, what is my radius? 5. So I'm out here, huh? Does that make sense? Where am I at pi fourths? 0, so I'm back here. Notice though, all the angles in between here, okay, that means the angles are getting larger. What's happening to our radiuses? Our radii? It's going down. So therefore, notice my radius is getting smaller. Notice they are going lower and lower, right? Does everybody see what I have there? Okay. Now, let's do this part. From pi fourths to pi halves. Notice, that's this section. But look at our radius up there. What are they? They are negatives, aren't they? So what do I have to do with a negative radius? We have to push through. So notice, I'm still going to have this angle here, but I will be in this portion. Okay? When I hit pi halves, I should be at negative 5. Pi halves negative 5. Then I have to push through, so I am down here, correct? So it gives me that look. Because I had to push through, didn't I? Okay. Now I got to go back from pi halves to 3 pi fourths. Well, at 3 pi fourths, I'm back at 0. But notice it's still, all this section has, that's the angles, from pi halves to 3 pi fourths. But notice all the radiuses are negative. So notice it just comes back up. Okay. Is everybody there with me? Okay, we're still going. Now we need to go from pi to 3 pi fourths to pi. Notice all my radiuses are positive again, so therefore I'm going to be creating this look. Now, that's the end of my cycle. Is that what our graph looks like? It's not, is it? So what could I keep doing? I could do another cycle, go to 2 pi, couldn't I? Does that make sense? Or I can see if it has symmetry. Okay, what kind of symmetry does this look like it has? Well, anytime I see a cosine one, guess what symmetry I'm going to go for? The polar, the one that you replace r with negative r. Okay? Not negative r, I'm replacing r theta with r negative theta. If it has that, it will reflect over this axis, which it does. We're just going to do it now. R equals 5 cosine of negative 2 theta. And once again, every time we have a negative inside there, what does it do? Cosine absorbs it. Did I get back to the same graph? Okay, so therefore it has symmetry. So I'm going to do the symmetry in black right now. Let's do blue. So notice this has symmetry about this axis. So therefore this guy's going to come over there, huh? Everything that's down here is up there. Everything on this one's going to come back to there. And notice it has 4 petals. It is so pretty. Okay? So notice I use symmetry to finish that instead of doing another cycle, though. Could I keep going with another cycle? Yes, I could have. Okay. Notice a little hint. If it is a cosine graph, you always double this number, and that tells you how many petals there are. If it is a sine graph, okay, if it is odd, it tells you the number of petals. If it is even, you will double the petals. So how many petals would this guy have? 4. How many petals will this guy have? 3. And in cosines, guess what? You're pretty much always going to double them. Okay? All right. You guys will have a pink worksheet today. There's 12 questions to graph. Okay, that is your homework. Appreciate you guys. Next week is our test. For A Day, you will be on March 29th. For B Day, you will be on March 30th. Okay? All right, guys. Thank you.